Okay, Rachel, now it's theorem 10.9, okay? Theorem 10.9, what does it say? It says, if a right angle triangle is inscribed, you know what inscribed means? It means to put something inside something, okay? That's what inscribed means. And circumscribe means to put something directly out of something, touching that thing. So inscribed means put something inside something closely, touching the edges, and circumscribe means put something around something, to envelope something around something. It's what circumscribe means. Okay, so if a right angle triangle is inscribed in a circle, then the hypotenuse of that right angle triangle must be a diameter. Here's the picture. So we have a right angle triangle, and it's inscribed in a circle, of course, as you can see. What this theorem is saying is that because if it's a right angle triangle, and that's the right angle there, then the hypotenuse of that right angle triangle, which in this case is a segment AB, must be the diameter of that circle. That's the theorem. Again, this one, if you accept theorem 10.7, this one follows. Because remember, what is the arc? What is the arc in this case? The arc will be that. The arc is this. Arc AB is this. So from arc AB, then you have this angle here. You have this angle, this right angle, as your inscribed angle. Remember we did before an inscribed angle for this arc AB. So arc AB is the arc that's intercepted. Arc AB is the arc that is intercepted by the inscribed angle here. Okay? Now, what is the measure of angle AB? Okay? The measure of angle AB is what? Will be one that we take back to the center. We have to take it back to the center. So if we didn't know that this was a diameter, we must at least take this back to the center. So let's pretend we did not know that AB was a diameter. But because arc AB, the measure of it must go back to the center. And therefore we know that this angle here must be twice this angle, and therefore this angle must be 180 degrees. And if this angle is 180 degrees, then this must be a diameter. I hope you follow that proof. It's fairly simple. We're not proving it from scratch. We didn't prove this from scratch, but we prove it with 10.7, with theorem 10.7. That is, if you already know how to prove 10.7, or you accept theorem 10.7, then you can prove this. Because again, remember, you have arc AB, okay, which is the inscribed angle associated with this is this angle, and we know we're given. It's part of the condition of the proof. It's a right angle. It's part of the condition before the theorem. Okay, it's a right angle. So, if it's a right angle, it means that the angle at the center for AB, the same AB, the angle at the center from theorem 10.7, which says their angle at the center must be twice the inscribed angle at the edge of the circle. Okay, that angle must be twice this. It means the angle at the center must be 180. And if it's 180, then it must be a diameter, because it's a straight line. is what it means. And if it's a straight line at 180, it must be a diameter. Because this line, this point came back to the center. The center is what we use to do the twice of that. The angle at the center. The central angle, okay? I hope it gets clear to you. You have to think about these things, you know. It's not difficult, but it involves multiple steps of logic. So, I mean, I expect you to be able to get this based on what I've just explained to you now. Okay? Oh, so that I don't forget, by the way, there is a corollary, if you will, of this same theorem, of theorem 10.9, which I just did in the last frame. There's a corollary of that that says if the hypotenuse, if the diameter, the corollary says if the diameter of a circle is one of the sides, if the diameter of a circle is one of the sides of an inscribed circle, inscribed triangle. Listen to me again. If the diameter of a circle is one of the sides of an inscribed triangle, then that triangle must be a right-angled triangle. It's just reversing this, okay? They call that corollary. That is, instead of going from this condition and saying this must be true, you start from this condition and say that must be true. So again, the corollary is this. So it's the same theorem 10.9. If the diameter of a circle is one of the sides of an inscribed triangle, then that inscribed triangle must be a right-angled triangle, and the right angle must be opposite that diameter. Okay, I hope you got that.